Hello my friends, in today's video we are given a triangle ABC such that the green angle is 100 degrees, the blue angle is 30 degrees, then we have a point D on the interior of segment AC such that BD is equal to AC, and the question is to find the length of angle ABD. So, before starting this problem, let's prove a quick proposition which we'll be using later in this video. Suppose we are given a circle with two equal chords AB and CD. We form line segments AC and BD, and the question is to prove that AC is parallel to BD. So, we construct segment AD, and if we observe the blue and the green angles, they intercept equal chords. Therefore, according to a geometric theorem, these two angles must be equal. But these angles are alternate interior angles of the white lines, and they are equal. Therefore, the white lines must be parallel. Let's return now to our original problem. We construct the circumcircle of triangle ABC, and we find a point T on this circle such that segment BE will be equal to AC. We construct EC, and now, using the proposition we just proved, because BE is equal to AC, we have that chord AB is parallel to chord EC. Because of that, the pair of angles on the same side of the traversal line AC must be supplementary. From that, we can calculate the remaining light blue angle to be 50 degrees, so that the light blue plus the green angles sum up to 180 degrees. Now, this white quadrilateral is cyclic, therefore the pair of opposite angles must be supplementary, and so the yellow angle will be 80 degrees. Now, focusing on this white triangle, sum of interior angles is 180 degrees. From there, the remaining angle can be calculated to be 50 degrees. As we can notice, this triangle has two angles both equal to 50 degrees, therefore it's isosceles, and B equals to EC. Now, let's remove these lines because we won't be needing them anymore. And let's find a point F inside the circle such that if we construct EF, it divides the yellow angle into 20 and 60 degrees. And let's extend EF until it meets AC at a point H. Now, for this point H, we can distinguish only three scenarios that could possibly exist. The first one is that this point H lies on the interior of line segment AD. The second one is that point H lies on the interior of line segment DC. And the third and final scenario is that the point H coincides with point D. Now, if we somehow manage to prove that the first two scenarios are false, then the only thing that will remain is that H coincides with point D, and that then must be true. So, let's assume that the first scenario is true. So point H is somewhere on the interior of AD. Observing this white triangle and using sum of angles equal to 180 degrees, we calculate the remaining angle. And we notice that this triangle has two angles both equal to 80 degrees. Therefore it's isosceles. Now we form BH and we focus on this white triangle. It's an isosceles triangle with the apex angle equal to 60 degrees. Therefore we can easily show that it's equilateral. Now let's remove these lines in order to see more clearly, and let's focus on this white triangle. We can see that BH is equal to BD, therefore it's isosceles. And because of that, the two blue base angles must be equal. Now, the base angle to the left is external angle of this white triangle. Therefore, it must be bigger than the remote angle of 100 degrees. Now, returning to this isosceles triangle, the two base angles summed up are greater than 200 degrees. And that's impossible because all the three interior angles of this triangle must be equal to 180 degrees. Therefore, point H cannot be lying on the interior of AD. Moving on to the second scenario where H is somewhere on the interior of DC. Again, using sum of angles equal to 180 degrees in these white triangles, we calculate the remaining angle, which is 80 degrees. And we can see that this triangle has two angles both equal to 80 degrees. So it's isosceles, and EH equals to EC. We form BH, and in this isosceles triangle, the apex angle is 60 degrees. Therefore, it's equilateral, and so BH is equal to BD. Now, on this white triangle, we conclude again that it's isosceles, and we apply the same logic as we applied in the previous scenario. The angle BDH is external angle of the blue triangle, therefore it's greater than the interior angle of 100 degrees. And if we sum up the two base angles, they will be greater than 200 degrees, which is impossible. Therefore, point H cannot be lying on the interior of DC. So, the only thing that remains is that point H coincides with point D, and that must be the case. Again, on these white triangles, using sum of angles 180 degrees, we calculate the remaining angle, 80 degrees. Therefore, it's isosceles triangle. Focusing on this white triangle, we can easily see that all its sides are equal, therefore it's equilateral. Because of that, each of its angles is 60 degrees. Now, the angle ADC is 180 degrees, and it's equal to the sum of the black, the blue and the yellow angle. From that, we can calculate the black angle equal to 40 degrees. Finally, we apply sum of angles 180 degrees to this white triangle, and we find the remaining angle ABD 40 degrees. So we found our answer. This was the proof. Thank you for watching this video, and I will see you on the next one. Take care.